Okay, we're in your geometry. We're in section 6.2. We're going to go on through section 6.2 to section 6.5. So you can look at these sections. We went over this part of the section 2 already, so I'm not going to repeat myself. Let's go on to section 3. So your quiz goes over section 2 in this next section. So. Okay, similar regular polygons. Theorem 79, regular polygons of the same number of sides are similar. So if you have a regular polygon that's 5 sides and it's regular, a smaller one's going to be similar to it, right? That's why they call it similar. And a smaller one or a bigger one, as long as it has, you know, regular, it's regular, all these sides are equal, they're all going to be similar. Okay? On to the next theorem here. Theorem 80 says the perimeters of 2 regular polygons of the same number of sides have the same ratio as their radii, or radius, the plural of radius is radii, as their apophthegms. So the perimeters, we're going to look at this now. The perimeters, here we have perimeters, perimeter, and the ratio of the perimeter is going to be the same as the radius ratio and the same as the apothem ratio. They're all going to be the same ratio to each other. So if you have, here we have 2 similar ones. So you're going to have a radius here, this ratio of this radius to this ratio is going to be the same as the perimeter, the whole perimeter ratio to this ratio, this one to this one. And this and apothem to the apothem is going to be all the same. Okay, the only time you have to worry about this is when we have areas. So when you're talking about ratios to ratio, the perimeters and apophthegms are all going to be the same ratio as they're going to be very easy, because you can say the ratios look like this. The ratio of one to the other is going to be all the same. Ratio of this to this, this to this are going to be the same. So corollary 80 here says, the perimeters of 2 regular polygons of the same number of sides have the same ratios as any 2 corresponding sides. So the perimeters means the distance around here, that's a perimeter, of 2 regular polygons, yep, has the same number of sides, yep, 5 sides, have the same ratio as any 2 corresponding sides. So this side is going to have the same ratio as the whole perimeter when you put their ratio together in comparison. Number 2 says the areas of any 2 regular polygons of the same number of sides are to each other as the squares of their radii, or as the squares of their apophthegms. So far, the ratios are going to be equal, but the ratios are all going to look alike. But now we have the area. Area would be basically, the area is going to be in square inches or square units, you know. So the area, say you had a field and you wanted to know the area of the field, they do it in square miles or square, right? So just remember, when you're dealing with area, you're dealing with square. So now any 2 regular polygons have the same number of sides to each other, they're similar, right? They're going to be squares, their areas, their perimeters are just going to be, you know, corresponding, but their areas are going to be squares. So you're going to put a square on the area. So you know that. So we'll just know whenever you have the word area, we're going to be talking about squares in square root, right? So this is section 6.5. So we have another theorem here coming. The area of a regular polygon is equal to 1/2 the product of its perimeter and its apothem. Okay, now we have another formula. K, whenever you see the word K like this, or the letter K like this, I should say, that's going to mean area. Because instead of putting A, because we're going to get mixed up with A and apothem, right? So they put K as the area. So don't let that confuse you. So it means K equals 1/2 the apothem, right, times the perimeter. So An area of a regular polygon is equal to 1/2 the product timesing the apothem and the perimeter. Make sure you half that. Because a lot of times you'll say, well, there'll be a question that says, do you just multiply the apothem times the perimeter and you're going to get the area? No. Here's the apothem right here. Remember, it's this line coming down here. So this is the center of, like the center of a circle. So it's going to be this times the whole perimeter, and you take 1/2 of that, and then you'll have the area. So the area being 1/2 apothem times the perimeter, and you're going to get the area. Okay? This, you have to know this one. Just think apothem and perimeter, half it, right? That's how I remember it. So let's see if there's anything else important. Okay, let's do the quiz, because the quiz just goes up to this point. Quiz 46. The diagonals of any regular pentagon are what? Well, they're equal. Page 264, number 16. So let's go look at 264, number 16. I didn't go over some of these up here. Some of them are kind of hidden. That's where this book does. So the diagonals is number 16. So let's look at number 16. It's starred, in fact. The starred ones are ones that we got to know. Prove that the diagonals of any regular pentagon are equal. So they circumscribed the circle around it, and they found that they were equal. So pentagon, basically any diagonals go across here. Let me show you a picture of it. Any diagonals that go across here are going to be equal. So the diagonals of any regular pentagon are equal. Okay. So number 2, an angle of a regular angle of a regular polygon and the angle of the center are what? We went over that, right? Remember the angle of the center. So let's let me do a little picture of this. So if we have a circle here and we have a polygon in it, let's do we're just going to do a rectangle in it. That's a polygon. So the angle of a regular polygon and the angle of the center. So basically you have the angle of the center being this angle here of the center, like this. Say this angle is like, this angle is really going to be like 180 degrees. So let's do a polygon that has a, okay, I'm trying to do one that has 6 sides. Okay, there you go. There's one. So basically the angle of the center. So this angle of the center, and we're talking about the angle of the center and the angle of the polygon right here are going to be supplementary. Now, if it said the angle of a regular polygon and the angle of the exterior, then they'll be equal. But the angle of the polygon and the angle of the center are always going to be supplementary. Page 265, number 9. We went over that already. Okay, so let's go on to number 3. So the angle of a regular polygon and the angle of the center are supplementary. If it said external angle, they'd be equal. The line that joins the center of the regular polygon to any vertex is a what? Radius. So we already went through that. Let's look at the radius here. Here's a radius. These are all radius. Go from the polygon, to the center angle. So here's the angle here. There we go. Those are radiuses. Basically the radius of that circle. So the line that joins the center of a regular polygon to any vertex is going to be a radius. Number 4. How many sides does a regular polygon have if each angle measures 144 degrees? Okay, so we need to know that how many sides does it have? First of all, we need to know each angle measures 144 degrees. So let's look at this picture that we had here. So each of these angles, say that you had each of these angles, and this angle here, which is this here, measured 144 degrees. So now we want to need to know, basically, so how many sides does it have? So basically, first we're going to subtract it from 180 because the center angle is supplementary. So we will take 180 minus 144 here. And what do we get? Do your work. 180 minus 44 is 36. So now we know the center angle is 36. We don't go by the we never go by the angle of the polygon, but we have to go by the center to find how many sides it has. You have to go by the center angle because then we'll know how many sides. Again, look at this picture. These are the center angles. So how many? We know how many 1, 2, 3, 4, 5, 6. There's going to be 6 sides because we have 6 center angles, right? So in the center divided by whatever. So now we now know how many degrees the center angles are 36 degrees. So how many sides is it going to have? So we take 360 degrees in a circle and divide it by 36 degrees, and we find out that it has 10 sides. So we have a 10-sided polygon. When the angle measures 144 degrees, the center angles are going to be 36 degrees because they're supplementary, right? So we subtracted that. So the center angles we're going to know makes it have 10 sides. Always go by the center angle first, okay? On to number 5. If corresponding sides of 2 regular heptagons, which is 7, I'll put a 7 there, although in this you don't really need to know it in this problem, but corresponding sides of 2 regular heptagons are 2 inches and 3 inches. What is the ratio of their areas? Okay, remember the areas have to do with square. Whenever you have areas, we're talking about square inches, square feet, square miles. Areas are always in square. So basically when we're comparing sides, we have to square them for the area. So here we have 2 regular, and we have one that's 3 inches. Here's 3 inches. One that's 2 inches and one that's 3 inches. So 2 square compared to 3 squared. So what is that? 2 square is 4 and 3 square is 9. So our ratio is what they want. What is the ratio? It's going to be 4 to 9. Basically, all we did was square these two numbers and compare them. 4 to 9. So this is on page 265, 82. Let me see, let me read that here. The areas of any 2 regular polygons of the same number are equal to the squares of their square radii. So here we just had to square them. We square them, and then we get the comparison now is 4 to 9. Right here it's 2 to 3, but we have to not just 2 to 3 would be if it was just normal, but since we're squaring them, it's going to be 4 to 9. Areas are squared side. Just remember areas, square. Okay, this looks like it's hard, but it's not. So whenever you look at like, oh my goodness, but it's not going to be it's pretty common sense. So, and we have a formula here. Whenever you have a formula, it's like, oh, good. We don't have to do a lot of work. So find the area of a regular hexagon that has a 4-inch side. So first of all, do you remember this? This is our formula here. I showed you that formula. We probably would have to need it. We do. So let's see. Right here's the formula in your book that we're talking about. And the formula is area equals 1/2 the apothem times the perimeter. Remember that one? So we're going to have to, with this regular hexagon that has a 4-inch side, we're thinking we're going to find the area. Well, first of all, we can use this formula, we need to know the apothem and we need to know the perimeter. So first of all, the perimeter is pretty easy because we know there's the hexagon, which has 6 sides, right? And then each side is 4 inch. So then we can find out, here it is right here. If we took all the sides, 1, 2, 3, 4, 5, 6, 6 times 4 is going to be 24. So we know that the perimeter is going to be 24 inches. That's easy. But the apothem now, we have to find out what the apothem is. Well, here's the apothem here if we know. Basically taking the apothem, this little area out here, this apothem is here. That's what we have to find out what that is, this little line. So here we have the side, this little triangle that's taken out of that hexagon. And so now we have over here, we know for sure it's 4 inches. So basically if this is 4 inches, this is an equilateral triangle. So if this is 4 inches, this is 4 inches, this is 4 inches. So we know that this is gonna be 4 inches. I just took this little triangle out here so I could see it better. So we have 4 inches, 4 inches, and 4 inches. Well, we wanna know what this is. So remember when we did that in the last quiz? So here we go. We're gonna use Pythagorean theorem because we have a right triangle here. See, this is our right triangle like this. I take out of there. So here we have, we know that this is 4 and this is gonna be half of that. So we know that this is 2. We wanna find that. So now we're gonna just use this Pythagorean theorem here. A squared plus b squared equals c squared. So a squared equal 2 squared, because these are legs. This is a leg, and this is the leg, and this is the hypotenuse, right? So a squared, because we don't know this here. This is going to be a. This is the one we don't know. So a squared plus 2 squared, we plugged it in, plus 4 squared, okay? So now we have a squared and 2 squared is going to be 4. So we have a squared plus 4. 2 times 2 is 4. And then 4 times 4 is 16. So we have 16. So now we want to find a square. Well, we can get rid of this 4 on this side. Subtracting 16 times 4, you get 12. So now we have a squared equal 12. Okay, a squared equal 12. So now we know a is going to equal the square root of 12. The square root of 12 in here actually is 12 is 4 times 3. So we can get rid of that 4 because it's a square. So we'll put that out. So we put that on the outside. So we have 2 equals the square root of 3, because 4 times 3, we got rid of the 4 by putting that 2 out there. 2 times 2 is 4, and now we have 3. So 2 times the square root of 3. We actually did the same problem in the last quiz, needless to say. So here we have, now we have, this whole thing that we found, this apothem, we found the apothem. So this is the apothem. So now we go back to our formula. 1/2 apothem times perimeter. We have the apothem and perimeter, so now we can just fill in the blanks. So we have K is the area, 1/2 apothem times perimeter. K equals 1/2, and we put in the apothem, which is this. 2 times the square root of 3 times the perimeter is 24 up here. Here's the perimeter, and here's the apothem. We stuck them in here. We stuck them in 1/2 this times 24. So we have 1/2 times 2, it's going to be get rid of this here now. Right there, we got rid of that. So now we have square root of 3 times 24. So the square root of 3 times 24 is going to remain 24 times the square root of 3 is going to be our answer. Make sure we put it down, find the area. I put down inches, but it's going to be square inches. Make sure you put areas. Whenever you find the area, it's always going to be in square inches or square. So, okay. So K equals 24 times the square root of 3 square inches. Okay, that's it for this quiz. Now we're going to go on to the next section.